Hi, everyone. Today we're going to go over lesson 3.4 over bisection. All right, so we're going to start with definitions. So if you have your theorem partial sheet at the back, there's a place for definitions. You might want to go ahead and put those back there. First one, midpoint. Again, the word tells you what it is. It's the point in the middle. A point is the midpoint of a line segment if and only if it divides a line segment into two congruent, which means equal segments. Okay, so the way that we indicate this on pictures is that if you have a segment and this point's in the middle, now I didn't, measure this out. Who knows if that point is really in the middle? But I want to indicate to you that B is in the middle of A and C. You would put these little marks, and those are called congruency marks. And that indicates that the two segments are equal. AB is the same measure as BC. Now, in the geometry world, we have a word that means the same measure, and that is congruent. Now, again, your textbook likes to make things sound much more difficult than what they are. The definition in your book says coinciding exactly when superimposed. And that just means the two images match up. They're exactly the same. If you were to put them like on a window where light would shine through or a light table, the two are exactly the same. So in the parenthesis is my definition. It's when two objects have the same measure. It could be segments, it could be angles, it can be a triangle, it could be lots of things. They just are exactly the same. Now the symbol for congruent looks like an equal with a squiggly tilde on top. And that means congruent. The person that wrote your book only uses that symbol during chapter 4 with triangles. I have no explanation for that, but really you can use equal and a congruent symbol interchangeably everywhere except for chapter 4. Angle bisector. Okay, so that's just a way to cut an angle in half. So you have an angle, and a ray bisects the angle to divide it into two equal parts. So again, who knows if I really drew it straight down the center? But I tried to draw BC as the bisector. The way that you would indicate that on a picture is that you would draw an arc and then put a little mark through it. And that would show me, hey, those two angles are equal, even if, we didn't draw it out and measure it. It's just a way to indicate it on a diagram or image. Okay, so now your book is very much of deductive reasoning. Take what we have learned and apply it. And it takes everything from past lessons and it spirals it, and it's just wonderful. Okay, so make sure you never forget. We're going to do a proof. Now, when you do this proof, we start with the given informations, and that's step 1. And your last step is what you're trying to prove. So before I even start, I know this goes down here. OC is equal to OW. I know it has to go there. Now, I don't know the reason yet. Okay, so I need to know how to go from step 3 to step 4. So I'm going to leave the blank for number 4 empty for now. Now, I'm splitting up my givens. So let's just start the very beginning, and I'm only going to write the first given in the first blank. Technically, if you were doing this 100% on your own, you could put everything in the first blank. So I'm going to say O is the midpoint. O is the midpoint, and I'm going to abbreviate of NW given. Now, rule of thumb, if you see a definition or vocab word, you're going to apply it, okay? So midpoint means what? Find NW, and O is the midpoint. So a lot of people just put a big dot there. That's not the way we indicate that's the midpoint. We know a midpoint means it's in the middle, so I'm going to put the two congruent marks on the diagram. Now, since it's the midpoint, I know those two segments are now equal. So I'm applying the fact that they told me it's the midpoint, and that deducts that, hey, I now know that NO is the same measure as OW. And what word did I use to help me come up with this? And it was midpoint. I had to apply the fact that I know the definition of midpoint. So from here to here, I put the reasoning. So because it was the midpoint, I now know what two segments are equal, and I justified it because the definition of midpoint. Now, I split my givens up to help make the proof flow. Again, you wouldn't have to necessarily, but I need to know how to go from up here to here. Now, we need to use all the information within the proof. We're never going to just look at the first step above. We're going to look at everything. Okay? Now, this is what I'm trying to get. Now, I noticed something. Right here is OC, and right here is OW. And these two are in common. Okay? So they're taking out the NO and replacing the NO with what it's equal to. And this is one of your properties. So what property is it where you take it out and you replace it? This is the substitution property. Make sure you don't write sub because that could be subtraction. Okay, so again, that is the substitution property. And we use step 2 and 3 to help get us to step 4. So every step is going to be important. You're going to have to apply it to help you get to your final answer. This is a direct proof. Okay, I believe this is the last proof here. Okay, so OB bisects AOC. So let's find out AOC. And so I need to mark it. So I'm going to put my little markings on the diagram. Now, look what we just did. I read the word bisect and I applied it. That's going to be important for our proof in a minute. Then we have ray OE and it bisects DOF. So let's find it. So I know these two are equal. And it also tells me AOB and angle DOE are equal. So AOB and DOE are equal. Okay, so let's recap. These two little angles are equal. These two little angles are equal, but these two angles are also equal. A lot to keep track of. Okay, so let's do this. On the left-hand side is your statements, and on the right is your reasons. So let's just write the very first given. OB, ray OB, bisects angle AOC. Now, this was given to me. What did I know? Because I knew the word bisect, it told me two angles were then equal. And it's these two up here. So let's label those. So I have AOB is now equal, or you could use the congruent symbol, to BOC. And what word helped me understand to do that? And that was your vocabulary word in the previous step, which is definition of bisector. Okay, so I dealt with that one. Let's go to the next given. Ray OB bisects angle DOF. Okay, and this was given to me. Again, the word bisect means it cuts it into two equal angles, so let's label those angles. I have angle FOE is now equal to angle EOD. And that, again, what word helped me understand that? Vocab word, definition of bisector. And I have one more given. So, again, rule of thumb, take your given, tell me what you can get out of that given, okay? So the first given, because of it, I knew it bisect. The second given, I knew that it bisect. This one, there's really nothing I can do to it yet. Now, we need to see how can we get to our final answer. Okay, so let's see if we can make this jump. Do I see EOF anywhere? Look around, EOF. Now, the problem is we can name angles two different ways. We could say EOF or FOE. So maybe you see this FOE here. Now let's look for BOC, which is up here. Okay, stay with me. Now, these are equal, right? Because, look here. Do I know what AOB is? Sure, it's up here in the green. And what's AOB equal to? It is equal to BOC. So I'm going to take it out and replace it with this BOC. Then I'm going to take the DOE, which is right here, take it out and replace it with FOE, which is here. And so we're actually doing a double substitution. And so you would just say substitution property. Again, do not write sub, at least put a couple more letters, substitution property. So again, you're going to have to go really slow, and I go highlighter crazy personally. And, I find the pieces and parts and see if those parts are equal to each other to do a substitution. We do lots of substitutions on proofs. All right. Now, a couple more vocabulary things and some corollaries. Okay, let's define a corollary. It's a theorem that can be easily proved as a consequence of a postulate or theorem. Okay, so the way I think of it is it's something that you can easily prove without me telling you. A lot of times it's common sense, but we need a way to refer to it within a proof. You can't just on a proof say common sense. We need a way to document it. So the first one is called the corollary to the rule or postulate. Again, this is something you know. A line segment has only one midpoint. Of course, we know that. But how would you document that or state that in a proof if we didn't have a corollary? So anytime that you need to reference that there's one midpoint, we will use this corollary. Same thing as with a protractor postulate. There's only one ray that can go right through the middle and bisect it. And again, that's common sense. We know that, but we need a way to document it if it comes up within a proof. Okay, so your homework is lesson 3.4. You have unlimited attempts on it. And then when you're finished and you don't have any more questions, take your homework check. Let me know if you guys have any questions.